Hey guys, today we are going to go over the stream ecology lab in which we're going to do a biodiversity assessment using the Shannon index. We're using that to assess two communities, the riffle and the pool. And then we're also going to do a health assessment using the Save Our Streams metric. We're using 4 metric groups: the EPT taxa, which includes mayflies, stoneflies, and caddisflies, the Gumphidae family for the 2nd metric group, beetles for the 3rd metric group, and metric number 4 is going to include more than a couple of species that are going to represent the tolerant species. There is a, what is it called? I think it's called a calculation help. It might be called something else, but it would be an Excel sheet in Canvas that has basically what I have on this sheet that I'm showing you right now. So it can save you some time in putting all of these tables in. So use that to get started. This video is going to be split up into the 2 parts. Like I mentioned, we're going to do the biodiversity assessment first, and then the Save Our Stream or SOS data calculation. There's also going to be, you have the abiotic data that you can use. It's relatively simple. We'll get to that. If you want more information on the biodiversity assessment using the Shannon index, you can look at the Brower and Czar handout on species diversity. Section 2.3 talks about the Shannon diversity index. There are a couple others that are mentioned in that handout, but we're just going to be using that Shannon index. So basically what we're looking at when we're assessing biodiversity is how does the community structure of the riffle and pool vary? What do they look like? The Shannon index uses this formula right here. It's H prime is the Shannon index, and it's going to be equal to the negative sum of P sub I times log of P sub I. So in this, we're going to be using the natural log. So this should be just ln. And it's going to be, it looks a little scary, but it's going to be easy. P sub I is the proportion of the total number of individuals that belongs to species I. P sub I is also known as the species evenness of a community. And if you remember from lecture, species evenness is the relative abundance of a species in the community. So like I said before, it's going to be the proportion of the total number of individuals within a community. The subscript I is referring to the I species, which is just going to be all of these that I have boxed out. It still includes ones that aren't boxed out, but they're not boxed because there's no occurrences that we saw in the assessment. So each one of these is going to be a different data point. I1, I2, I3, and so on. So when you get your data, you're going to have all your occurrences listed for the riffle and the pool. And we're going to calculate a Shannon index for both. Let's see. So to calculate the P sub I is going to be the sample size divided by the total, and become, oops. Okay, so down here, I have the total, which is 76, and that's just going to be the sum of this entire column. So to get P sub I, you're going to take the sample size and divide it by that total. When you have 0, it's going to be 0. Okay, and sample size divided by the total. That's going to give you your P sub I, or your species evenness for the ith species. And the last one that I'm going to show you for the pool. Okay. And you're going to do the exact same thing to find P sub I for the riffle. Then we're going to solve for the natural log of P sub I. Which you can put into Excel like that, and just take the natural log of P sub I. For those species that we did not see, the ln times the natural log of P sub I is also going to be 0. Okay, just taking the natural log of P sub I again. Obviously I'm not. Now I'm taking the natural log of P sub I. You can do this on a calculator or on a browser on the computer, or you can do it in Excel, whatever you want. I just prefer to do it all in Excel. There's definitely occasions where doing it by hand is easier. Okay. So as you can see, I've already done it for all the other species. So when we get to doing the full Shannon index, all we have to do is take the negative sum of this column to give us the Shannon index. And this column's easy because you just multiply P sub I times the natural log of P sub I. Let's see if that. Yep. So when you want to get the sum of the negative sum of this for your H prime value, you're just going to insert the negative before your sum. So I'll show you. You're going to put the negative and then write sum, and then select all the cells that you want to sum. And make sure you get all your parentheses. I probably always over parentheses, but the Shannon value is 1.76 for the pool. And we do this again. I'm going to do a couple examples for the riffle. To get the P sub I, you're going to divide the sample size divided by the total. And then take the natural log of P sub I. And then multiply those two columns. And you're going to do all of those again for the riffle. I know it's tedious, but you'll get through it, I promise. This is probably one of the more tedious labs out of the entire semester, at least in my opinion. So down here, we have the total for the sample size, the total for P sub I, and the calculated Shannon index. I'm going to go back up here and show you the formula again. That when we take the Shannon index, we're taking the negative of this entire last column when you sum it together. When you're going through your calculations, your P sub I column should all sum to 1. So if it doesn't, you're doing something wrong and you should go back and check that. So what does the Shannon index mean? Dr. Bissett talked in the recitation about a range of Shannon index value from 0 to 4. 0 would be there is nothing, there's no species there. It is not diverse, there's nothing there. And around, I think he said 0.6 or 0.3, I don't remember, would be 1 species. And if you have a Shannon index of 4, that would be an example of that would be at a tropical rainforest. So we have a Shannon index of 1.76 for the pool and 1.96 for the riffle. So where the riffle is more diverse than the pool is in this situation. But in terms of when you're comparing them, you just want to compare them to each other. How are they different? Or are they the same? The range 0 to 4 for the Shannon, the H prime value is not limited to 4. There could potentially be a value higher than 4. That is just a general range. So this value right here, H prime, considers the species evenness and the species richness of a community, using that to assess the structure. And remember, evenness is the P sub I value, and the richness is equal to the total number of species observed. So down here, you're going to see made a little table to look at, be able to assess the riffle and the pool and the entire community together, just to get an idea of what the species richness and evenness look like. So this first row is the total number of species per community, or this is going to be species richness. So what I did was just go through this data table and count the number of species that we saw. I'm not going to count the number of occurrences that we saw, just the number of species. So for the riffle, it was, well, we're looking at pool. So for the pool, it was 10. So it was 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Miscounted somewhere. But you get the idea. You just count them, not how many times each species occurred. You do that as well for the riffle, and if you add them together, that's going to give you your total species richness. We saw a total of 22 different species in the entire stream. The species evenness, if you want to report different values for evenness or P sub I, you can look at this column and report where there was 0, it equaled 0, or where the P sub I was higher than other species. Like here in the pool, the proportion of caddisflies was 0.43 versus majority of them are under 0.18 was the next highest. Stuff like that for species evenness. Total number of individual organisms is just these 2 totals for sample size added together, just for reference. You don't necessarily have to report any of these values. Report what adds to your paper and what you're going to talk about in your discussion. So that is really it for the Shannon Index Biodiversity Assessment. The next, we're going to move on to the abiotic data, which should be very quick. If you're in the Monday morning section and I gave you your data, I already took the mean of all the values for you. So you just report the means. If when we were out in the field, we took 3 data points. So you just want to take the means of those for each temperature and dissolved oxygen and for both communities. The Save Our Stream calculations are a little more difficult. Not as intuitive as the abiotic data, but we're gonna do our best. So what do I want to say about this? This is a separate survey from the Shannon Index, the biodiversity assessment that we just did. And some of the species that we observed for the Shannon survey are going to be part of the Save Our Stream survey, but not all of the species. So you'll see we have 4 different metric groups here, and they do not include all of the species that we saw in this list. So just be careful when you're adding up totals that you're selecting the right species. It can get tedious. Just double check your numbers. So the goal of this Save Our Stream calculation is to consider the ecological condition. We can determine the condition to be acceptable, partially acceptable, or unacceptable. And we're going to do this using 4 different groups to be metrics. In this analysis, we're going to consider the entire community, not just the riffle and the pool. It's going to be both. Ultimately, we're calculating a metric value, like you can see here in yellow. And here I have how you calculate this. This table that you have in the template on Canvas takes you through each step of it, but this is ultimately how you calculate it. It's the number of metric organisms divided by the total number of metric organisms multiplied times 100. I'm going to take you through each of the calculations, not all of them, but we're going to work through a couple. You're going to use the metric value that we determine with this formula to give each of these metric classes a score. And then we can use the score, sum them together, and it's going to give us a total that tells us what condition the community is in. Like I said before, it's going to be acceptable, partially acceptable, or unacceptable. So starting with the first metric, we have mayflies, stoneflies, and most of the caddisflies. This represents our EPT taxa, which are intolerant of pollution. This metric you can see in the pink, orange pinkish color. Metric 2 is the Gomphidae. We did not observe or collect. It just wasn't in our survey sheet. So this is going to be 0%. The third metric is in purple, and these are beetles. I am honestly not sure why they have their own metric group, but they are classified as being somewhat tolerant. And the fourth metric group in the green is a bunch of these species that are mostly, for the most part, are going to represent the species that are tolerant of pollution. So we're going to go back to metric 1. And what you want to do is count all the number of organisms that are in the metric group. within the riffle and the pool and put that in this column here. I've already went through and counted all of them. This can be really tedious. Like I said before, just double check your numbers and make sure that you're counting from both the riffle and the pool. But I'm not going to show how I count them because it is very tedious. And you're going to go through and do that for all of them. So for each of the metric groups, and it's all of these species right here. And then you want the total of this column. All of these, so you can calculate your metric value. So for this column, it's going to be metric 1, the metric value is going to be 104 divided by 208, which is the total of the column. And that's going to give you 0.5. And the only difference is you just want to multiply it by 100 for this column. If you want to just go through, you just want it to be a percent. It's just this copy column, but make it a percent value. I don't know why Excel's not letting me do it, but you all know how to make percents, so you got it. Like I said earlier, Gomfidae metric, there were no observances because it wasn't part of our survey, so all of it's going to be 0. For beetles, we're going to do this again. You're going to take the metric total number for the class and divide it by all the classes total. And then that's going to be 19%. So I'm not going to go through all of the ones from the 4th metric group, all of these guys, but you want to go through all of them, do what I just did, and then I'm not sure if your template sheet has the formulas put in for this, but you just sum all of the columns. So down here, sum that. You're going to divide the sum of that column divided by the total. And then that's going to give you your percentage for this entire metric group. Okay. So now we're on to giving the community a score in terms of ecological health. So what you're going to do is take the metric values that you just calculated for each class and copy them down here. And then based on the metric value, you're going to assess it, give it a score. They can be 6, 3, or 0 right here. So whichever the criteria it fits, you're going to give it the score that correlates to it. So for this one, it's 50%. I gave it a score of 6 because it is greater than 4.6. 0, got a score of 0. Beetles was 19%. So I gave it a score of 6 because it was greater than 9.2. And then for the last metric group, the tolerant species, the metric value is 31%, which is, it gave it a score of 6 because it was less than 67.9. All right. So you want to sum all of those scores up, and that's going to give you your way of ranking it in ecological health. This acceptable, partially acceptable, unacceptable is on that template. So since it was score of 18 and it is greater than 14, I gave it a score of being acceptable. So that's your H prime biodiversity assessment in the Save Our Stream ecological health determination are your largest data points for this paper, and I hope this helped make this a little bit easier. And as always, if you have any questions, feel free to email me or pop in on Discord.